Swayam Prabha. Digital India. Educated India.
Welcome back. In lecture 17, we will start Python programming, and this is part 1 of the lecture. And the concepts that we will cover will be on Python basics, arithmetic and Boolean operations, string operations, input-output operations. Then we will give you a demo of the programs we write within this. And then we move into functions, functions calling a function as argument of function, and then we will give you a demo for different function programs related with functions. So starting with when you want to start writing the first code in Python, it's not that difficult. For example, you don't have to write a lot of statements like hash include, IOStream, like we used to do in C, C++, and so on. So that means you can immediately start writing, and you just keep on typing in your ID, and more or less the way we actually speak in English, that there is not much difference in the way we write code in Python, because it's a very high level language. So along the way, of course, there are some syntax involved, but it's not that difficult to learn, and we will learn it along the way. So first we will of course write our first program today. And you can see over here, I've already listed a few lines in that particular program. All of them are prints. That means the program will print something on the screen. So what it will print hello urban world. Then it will print welcome to city analytics, planning smart cities, and so on. But what you see is the use of the quotes and the use of brackets. So when print is a function inbuilt in Python, so if I want to print something, it has to be within brackets. So, and then if I put quotes, that means that's some sort of a string that is getting printed. So print hello urban world within quotes, either it could be double quotes or single quotes, doesn't matter, both will work. So both of them will print hello urban world. In the output you can see that we are printing hello urban world and then welcome to city analytics and so on. Now if I want to print quotes within a string, because the string itself is within quotes, but we also want to put some quotes, so we give double quotes. So you can see over here, planning smart cities, we are able to print that. So actually this first quote will not be there, so that's a small mistake over here. So this quote will not be there. It starts with a single quotes, ends with a single quotes, and within that smart cities will be in quotes. Then print /n urban planning. The /n command moves text to the next line, so it's the next line command. And /t actually allows a tab to be inserted. And if I want to type in quotes, but it is not like an indicator of the end of that particular string. Usually when I put the double quotes, it means the string ends. But if I say that, well, the quotes is part of the string itself, and I don't want to end it, in that case I use a slash sign, and then we give that quotes over here. So print road width is 6 feet. We want it to be 0 inches, so that's why we have put the slash sign over here, and you can see it prints road width is 6 feet 0 inches. And then we can do some amount of indenting by giving the tabs, and then along with that, that's why this indented zoning test, this text came as a little bit indented on one side, and then eventually we can print 5 blank lines using this repeated number of this /n's. That is the next line command we are repeating 5 times. So here I have not shown that, but it's not possible, but there are 5 gaps, and if you print something after this, it will come after 5 lines. Now coming to arithmetic and Boolean operations, again everything is not much difficult, it's pretty simple. And the other thing that you want to understand is, like whenever I'm storing some variable, some data in some attribute like road width is equal to 12.75, you don't need to specify what kind of variable it is, like is it an integer, is it a float, because it's 12.75, there is a decimal involved. Automatically Python knows that this is a float, and it will make road width into a float variable. Now similarly, rounded width could be a float or an integer, but because I'm rounding road width, that means it's most likely would become an integer. And then length is equal to 2, it's an integer because there is no decimal or anything involved. And then footpath width is equal to 1.5, so that's a float variable. And then total width, we are doing the first arithmetic operation, is equal to length multiplied by 3.5. So length is whatever is stored within length, that is 2, will be multiplied by 3.5 plus footpath width, which is 1.5, and it gives that total summation is stored in the variable total width, right? And this is the first Boolean arithmetic operation that you are doing, and then we can print total width, which will print the actual result. And when you do that, you will get an output of 8.5. So you can type in this command in your Spider ID or your PyCharm ID, any one of them, and you can just run the commands, and you can see that this would be the output. So that is for your own practice. You need to test those. Now that we are declaring some variables, right? So that means road width, rounded width, these are all variables, right? So inside a program there are two kinds of variables. One is a global variable, other is a local variable. The global variable means the same variable could be used all across the program. That means because we are usually, when we declare a global variable, we declare it at the beginning, and it is it is not within any kind of functions. We will also learn about functions. That means functions are a group of code which you can call again and again by the name of that function. That means you don't need to repeat or type that code again and again. If some code needs to be repeated and needs to be called again and again, I can combine them and form something like a function or a group of statements that would be executed. So this function, there could be variables declared within that function, which is only, that means the steps that you write within the function would be based on those variables which are declared in the function. So those would be local variables, right? So variable in a specific function are known as local variables, but global variables are those variables which are declared outside the function, and we can pass those inside a function, and then the function can return those variables back. So that means the variable value keeps on getting changed, right? And so that's a global variable. So in procedural programming in earlier days also, we used to have this kind of global variables which was passed in different functions, and we discussed that earlier, that the problem with that was it was difficult to track that variable, and because some function may change something and we don't know where the error is happening, it was that way it was difficult. So now in Python also we can do exactly same. That means we can write it like a procedural language, but we can also because it's an object-oriented programming language, we eventually will write our code in form of classes and in form of objects and so on. That we will show you later. But in general, variables could be declared both as global as well as local, and based on the way we are using the variable, we can control who can access those variables, or how the variable's values needs to be preserved, or so on. And if you want to delete a variable, keyword del is for deleting variables. Now look into the next program, which is we are measuring, we are trying to see if the FSI of a particular building is violated or not. So the FSI is 2.5 for a particular building. We are storing the value of FSI in the 2.5 in the variable FSI, and then maximum FSI value is 3. Now I am checking if this is exceeded. So how do I do that? Forget the print part first. Just see FSI is greater than equal to max FSI. So this greater than equal to actually is checking less than or equal to, and so it's a Boolean operation. So any Boolean operation, the value that is returned is true or false. So if it is true, then it returns a true statement. If it is false, if FSI is not lesser than equal to max FSI, then it will be returning a false, and that value would be printed because everything inside the print function. So then eventually I am saying print FSI violation. I am typing that out. comma, and then the actual value, that is FSI is greater than max FSI or not. So in the first statement you see that when I say FSI is lesser than equal to max FSI, so obviously it is true, so it is printing true. Then next I am printing FSI violation as a text, and then I am saying FSI is greater than max FSI. That is not true, so it will print false. So that is how the output has come over here. Then coming to string operations, over here we can also, same way we were adding numbers, we could add strings. So this is known as concatenation. So over here, zone 1 is one string variable where automatically it is Python saves it as a string variable. So we take residential, we store residential in zone 1, and similarly we store the string commercial in zone 2. Because it is string, it is in quotes, and then we just simply add them up by saying zone 1 plus zone 2, and within that also I am adding the sign, this plus, using the quotes. So because it is within the quotes, it is treated as a string. So zone 1, and then we are adding this particular string which is a plus sign, and then we are again adding this string zone 2. So together it would be residential plus commercial, and that is getting printed eventually. So that is what the output shows. Now then comes something called very important, F strings. So these are also known as formatted strings. Now what it means is, if I want to replace, if I want to type in a variable, that means if I put F at the beginning and then curly braces after that containing expressions which can be replaced with the value of those expressions. That means I can change. If I say population and then population is storing 10,000, actually it will be printing 10,000, not the word population, right? Now what is the benefit of it? The benefit of it is, if I can, if this population is form of a array or a list, which we will teach you after this later on, that means it contains not one value, multiple values, and then I can put the code in such a way so that it prints the first value, second value, third value, fourth value. So using the same command I can do that. That means the population, because it's a list or it's an array, its value will get replaced again and again, and but the print, this command I don't have to write population, I have to write multiple lines of that, right? So that is the benefit of this F string. So in this program you can see the city name is Kharagpur, which is a string. Then population is 100,000, which is an integer, and then I am printing this F string where I am mentioning F, and then this city, this within the brackets, the value of city actually means that this city would be replaced by the actual value which is there, that is Kharagpur, and population would be again replaced by the actual value that is there. So when I print out, it will print out city Kharagpur, population 10,000, 100,000, sorry. And then the final program, if you want to print something just for display purpose, you want to print, multi-line text like this, you need to put in triple quotes. That's again a syntax. And when you do these triple quotes, we follow the same way it is being listed in the program. We will print that in the same way. So the output would also look like urban development report, then the line, and then the 3 lines of land use mix, density high, and status approved. Then looking into input or output operations, for example, in this particular program, what we are taking is, we are taking input from the user. That means a person will type in the input. So the function for that is, the syntax is, we use the term input, and within bracket enter population is the text that would be shown in the screen. And once you type that value, it would be stored in a integer. It would be an integer value that would be taken, and it would be stored in this variable called population. And then what happens is, that means then I can print that particular population for, just, or I want to do anything with population, like we want to do some calculations and all, we can do that. So this I didn't explain that earlier, but this hash actually is basically a comment. That means this line will not get printed. It is just for information, right? So whenever I put hash and write something after that, that means that becomes a comment until unless I go to the next line. So So here input reads text and int converts it to integer. So whatever value you are entering, it would be converted to integer. So when I run this program, what happens is you get a prompt in the screen called enter population, where you enter the value, and then it takes that value, that population value, multiplies it by 2, and then prints it. Say print f string projected population colon, this within curly brackets population multiplied by 2, and you are printing 40,000 for that, right? So that means star, of course, is it performs a multiplication. Then coming to the next program, what we are doing is we are doing a little bit larger, input output operation, where city is Kharagpur, ward is 12, road width is 12.75. These are the different variables that we are storing. And then rounded width is again, we are rounding the road width into, that means we are converting a float to the nearest integer. And then again we are having FSI values, maximum FSI values, and the permitted FSI value is equal to, then we are doing a Boolean operation. That means FSI is lesser than equal to max FSI. If it is fine, then it is true, otherwise false, right? So, and that true or false value would be stored within permitted. So permitted would be a string variable. So finally, I am printing print f string within curly bracket city. So it will print the city's name. Then there is a comma. Then there is w. Then it will print the ward number, and then it will go to row. Then road is equal to rounded width. So it will take the value of rounded width and print that. And then m is added, because we will like to add the meter because it's in meters, so we are adding the m as a string. And then finally I'm saying FSI is okay or not. So within curly brackets I'm putting permitted. That means it would be true or false based on the condition it satisfied. So over here, of course, FSI is lesser than equal to maximum FSI. So this FSI is 3.2, which is not less than maximum FSI, so it is returning false. So output is Kharagpur, W12 colon road equal to 13 meter. FSI okay? No, that's not okay, it's false. So let's see a little bit of whatever we have shown you. Let us see the programs when we type it out in Jupyter Notebook, how it is executed. So you see all the programs that we have just done. So those are being run on the screen, and you just type in those. It's so easy, and then you run those and you will see the results, and you can keep on modifying to check what changes. You can do some changes in the syntax and so on, and and if you do that, then automatically you will become familiar with the programming in Python gradually. So these are the examples that I just explained. Then coming to another group of, another important thing in Python programming, which are functions. That means once we have learned the basic mathematical operations, now we can move into functions. As I told earlier, a function is a named group of statements that executes only when it is called. So that means if I call a function, whatever code is written within that, or whichever codes are grouped together within that function, those would be executed. So functions help in organizing code which avoids repetition and also improves clarity of the program. That means what exactly we are doing, we can understand. Now it also allows us to combine together different lines of code, and a person who is a user of a program may not need to know the details of the function, but he should know what gets into the function and what comes out of the function, right? So there are a lot of built-in functions in Python like print, length, round. So this we already have learned, but what we are talking about is mostly the user-defined or the custom functions, that how you can write a function on your own. So a function call is a request to execute a function. Statements inside the function body are executed, and functions can accept arguments. That means there has to be some input going into the function, and once those inputs are taken in, those are used to do the computations within the function, and then a function always has to return a value. In case it doesn't return a value, we have to specify none. That is, none is a no value is returned. But in most cases, in all other cases, it is assumed that a function will return a value. That means there has to be a return statement, return something, right? So that means those value would be returned, and that could be stored in an integer or something, right? So in Python, functions are considered as first class objects, right? Not only functions, eventually we'll see that classes are also considered as first class objects. Now what does that mean? That means a function can be passed as an argument to another function, right? And that means a function could be part of another, could be sent to another function, and a function can return another function. That is also possible. So that makes it very flexible. Now, within a class, later on when we will learn classes and instances and so on in object-oriented programming, you will see that there are also functions that we use there, and those are known as methods. So how do we define a function? We use the syntax def function name, and then within bracket we put all the arguments that we need to pass to the function. That means we will put in all the parameters which are required to be put in the function, so that those parameters would be used for doing some calculations or some checks or doing some conditional checks and so on. And eventually that body of the function will contain all those code, and then eventually the function will return something. So and at the end of this we put in a colon just to say that, well, that's the end of the definition of function. Now the next would be the statements of the function. So let's see our first function, def road underscore area. Two parameters as being passed, length and width, and then what we are doing is we are declaring a variable. So this is a local variable to the function. Area is equal to length multiplied by width, and that means whatever length and width you send to the function, that would be utilized to calculate the area of the function. And then it returns area. That means this particular function will return the estimated area of that particular zone or that particular shape. So then we can print that road area. Then we can print how we can call the function as well as print it. So road print within bracket road area 512 is both calling as well as printing the function, right? So how we are calling it? We are calling it by just typing in its name, road area, and within that I am passing the argument 15 and 12, and all of this would get print because it is going to return something. That thing would get printed. That's why it is within the print function. So and what we will see is the output would be 6000, because it would be multiplying length and width, because we are passing on 512. When you multiply 500 with 12, it would return 6000. Then coming to the next program, which is we define a function called development decision, where we are passing on 4 things: city, the name of the city, the name of the ward, the road width, and the FSI, right? What we are checking is the land, the policy for development will be approved or not. So when will development approved? It will be approved when the road width is okay, the road width is adequate, the FSI is adequate, or the FSI is not violated. So then it would be development would be approved, right? So in this case, what we are doing is we are storing max FSI as 3, and then minimum road width as 12. That means a building would only be allowed if it is within the FSI limit of 3, and if the adjacent road width is more than 12 or like that. So then we are doing road OK equal to road width greater than equal to minimum road width. So whatever road width I would pass into this particular function as an argument, it will be checked against the minimum road width. If it is true, then it would be stored in road OK, right? And if it is that means if it is greater than that, then it would be stored there. And similarly, FSI is also being checked. FSI OK is equal to FSI is lesser than equal to max FSI. If it is true, then it would be again stored in FSI OK. Then what we are doing is we are checking if road underscore OK and FSI underscore OK colon. Now what is not given over here is this. What it means is road underscore OK equal to true, and FSI underscore OK equal to true. But you don't need to type in that, right? By default, it takes it as true. So if both the conditions are true, the decision is approved, that we will store the value of approved in the variable decision, else we will store the value of not approved. So that's the function, right? Now returns the decision. Finally, this decision value, either the string value, either approved or not approved, is being returned. Now, how do I start the main program? So, as soon as return is encountered, the Python interpreter will understand that this is the end of the definition of the particular function. Now, it will start executing the codes after that. That means, first city, it will take an input of enter city name. That means, enter city name would be displayed and you need to type in your city name. Then it would enter the word number that you have to put it, and it would be converted into int and then stored in word. And then you will enter the road width in meters, and then again it would convert that particular input into a float value and then store in road width. And then FSI value is again stored. That means you are again entering the proposed FSI, and then it will be taken as input and stored, and then after it is taken as an input, it will be stored as a float variable, and then we run the actual function. How do we do that? And we are storing the value of the function that will be returned in the variable result. So, result is equal to development underscore decision, which is the name of the function, and within bracket I pass on all the arguments like city, word, because we already have city name that is stored, that you have entered would be stored in the variable city, then word, road width and FSI, and then I am printing print f string city, word. These are the things that would get printed, the actual and the development status, which is the nothing but the result. So, result is basically the call of the function development decision. So, what happens? So, development decision is this particular program which is given at the beginning, development decision. What the arguments are city, word, road width, which we are passing over here at the bottom as well. So, when we are putting all these values, it takes the FSI and then it checks, it takes the road width, it also checks. And so, if you enter a road width which is more than this, then everything would be okay. If the FSI is less than this particular 3, the value, the decision would be approved, otherwise not. So, over here I entered the name of city name as Kharagpur, then enter the ward number as 12, then enter road width as 14, which is higher than 12 definitely. So, that means it will be approved, and then enter the proposed FSI 2.8, which is lesser than 3. So, when the model is being when the function is being called, automatically it checks, and then if it puts in through this loop, if road underscore OK and FSI underscore OK is true, then decision is approved, and now we find our decision to be approved, and that is eventually getting printed using the f strings here. Now, in case I want to check if it is not OK. So, in that case I will type in if not road OK and FSI OK. So, that means it is not conforming to true, that means it is false. So, this is an example of a function calling a function. A function can execute one or more other functions within its own body. This actually reduces repetition of the same code and all, and we can reuse that particular function everywhere within within another function also. And duplication of code is avoided, and it ensures consistency in computation. That means the structure of the function remains same. I don't have to bother about every time when I have to type in a new function what is happening there. So, because it's written and it's saved once, as soon as I call it, the same function will be called. So, there will be no there will be always consistency. And then decomposition of complex problem into smaller, manageable, well-defined tasks. So, I divide my program into small tasks, and then I can repeat or call those tasks again and again. And programs becomes modular, readable, and thus making them easier to debug, modify and extend. So, let us see the program. So, what here we are doing is we are checking if the water supply is adequate. So, def check water supply, and within the argument passed is per capita supply, and minimum required again is 135. So, we all know that. So, return, what the program returns is return per capita supply is greater than equal to minimum required. So, what it will return? It will return a true or a false statement. If it is more than 135, it will return a true. If it is not, it will return a false. Then what I am doing is then I am writing a function which would call this above function. Now, that new function is def water status area name supply, and area name supply is the argument that is being passed. Now, adequate is equal to check water supply. That means I am calling that earlier function now. So when I am calling that earlier function, I am passing on supply as the argument, right? So what was supply in this particular case? That means that whenever if this supply is nothing but the we will pass. So this is the structure that we are first doing, that is check water supply. Within check water supply, I am passing an argument called supply, right? And this supply is a function. I am not defining it directly right now, but it would be, when I say that, well, this name of the this particular supply would be check water supply function, then automatically that you can understand that. So adequate is equal to check water supply function calling a function. If adequate, return adequate water supply, else return inadequate water supply. Now going to the main program. Now here I don't have to say def main, but sometimes we can also say def main. That when you say def main, that means it's the main program. Main program means it is the from where the execution starts. So that means it starts from the first line of the main program that would go after that. So what is happening? First line, area, we take an input of enter area name. So like over here in the output, you say when this code is run, this line of code is run, you see enter area name on the screen and you type in Hijli, right? Hijli is in Kharagpur, inside our campus. That area, one part of the campus. Now supply is equal to float input enter water supply LPCD. So now I am taking the value of LPCD in this particular area. So the value shows as 140. Then what happens? The result is equal to, we are storing the whatever the value I'm storing in result. What value I'm storing in result? Water status within bracket area and supply. Now this area water status is the name of what? The name of the function water status. Area name is the area, the name that you will enter, right? So that's going as an argument. We have already defined this function which takes in two arguments. One is area name and the other is supply. And then supply is basically the amount of water that is being supplied, right? So that you have typed in. So then this, when it goes into that argument, so what is happening in the water status program? What you are getting is you are getting Hijli and 140. So then what it will check? Adequate is equal to check water supply. So check water supply 140, that would be checked. Check water supply program we have written already earlier, which is at the beginning, check water supply per capita supply is the argument for that. So that would be 140. So when we do that, automatically that results will be returned, that is it is adequate, right? So that means supply is greater than equal to minimum required, so it would be true will be returned. So when it is true, that means if adequate is equal to true, automatically it will return adequate water supply. So what we see over here is printf area result. So printf, it is printing Hijli and we are getting adequate water supply. Finally, coming one example where we show function is again passed as an argument of a function, right? We are not calling a function within a function, it is a function as an argument of a function. So over here in this program, you can see the first program is def streetlight underscore rule lights per kilometer. So what it does is it returns if the lights per kilometer is greater than equal to 30, then it returns as true or false and so on, right? So that means it is a rule that per kilometer it has to be more than 30 lights, right? If it is not, then it would be showing that that value is not satisfied, so it would be false. Now we have another function def evaluate area where the arguments taken is area name, the value and the rule, right? A rule is, let us assume that rule is something, right? Later on what we will do is we will pass this function within that particular rule argument. So rule is a function that will be passed to this particular argument. So status is equal to rule value, that means whatever you put in over there, and this value is the what you will enter, like area name value means you will enter a value of how many street lights are there per kilometer, and once you put that, that value goes as an argument to the rule function. And if status is equal to true, then it will return standard met, else it will return standard not met, right? Now the program says that if status is true, then it will return standard met, else it will return standard not met, right? So now that function definitions have been ended, so now the actual main body of the program starts. Area is equal to input, enter area name, and you enter the name of the area. Then lights is equal to float, input, enter street lights per kilometer, you say 20, 30, whatever you feel like, right? And then what happens is, we are calling the evaluate area program, and we are passing this area, lights and street light rule as the argument, which is nothing but another at the function at the beginning that has been declared. So when you call that function street light rule, what it will do is, that means this particular function will actually evaluate if that value of 30, whatever you enter, is greater than 30 or not, right? So that means over here you see that the street light rule, when you are putting that as the argument to this particular function, evaluate area function, then this rule value that you will get. So this rule over here that is being called, and we are passing this argument value. Value is nothing but the lights over here, right? So that when it is passed, automatically it will check that it is greater than 30, and it will return it is that standard is met, not, and standard not met will not be printed. So when I print that result, that whatever is coming out of this return, that is stored in result, then printf area and then result, and you can see that technology standard is met, right? So actually this standard met is being printed, and if area, I think this name of the area is technology, that's why it is saying technology standard is met. Now why technology? In IIT Kharagpur we sometimes call IIT Kharagpur as technology, right? It's a technology campus, so short form is sometimes technology. So it's not like, you know, anything else. So name of the area is given as technology. So these are the examples that we have just done. So we have just run those programs to show you that, yeah, all of the code is fine and it's running. So you can type in the code, and then you can see if it is working or not, and eventually you have to write your own code, and you can do some new things and you can practice using that. So in this program we are checking that adequate water supply thing, and we are getting, yeah, Heisley adequate water supply. And then over in this particular program we are checking the street lights, if the standards are met or not, and then we can, you know, find about that. So we can test all the things, that is function within function, function as an argument, all the different things could be tested, and you can actually do some programs of your own. So these are some of the references we have used. And to conclude, this lecture lays the foundational building blocks of Python programming. In subsequent lectures, these basics will be extended to handle repetition, data collection, and more complex urban analysis tasks. Thank you.